Hi, everybody. Okay, we are ready for 8-4. So not only did we learn how to graph a quadratic parabola and a quadratic function, which was extremely exciting, of course, we are now going to learn how to transform it. Think all the way back to Unit 3 when we did geometry. And we did transformations, and we moved polynomials around, and we used lines, and we moved them around on a coordinate grid. We are going to look at a quadratic parabola, and we are going to transform it. Very exciting. The width of a parabola. All right, ax squared plus bx plus c. The absolute value of a, coefficient of x squared, determines the width of the parabola. So that a, the coefficient, decides how wide it will be. The larger the absolute value of a, the narrower the parabola. But that makes sense because you're multiplying times x squared. And the larger a value times a squared value is going to go up faster or down faster. So it makes sense that the larger that a is, the more narrow the parabola. The smaller the absolute value of a, the wider the parabola because it has more time to go up or down. And they're using absolute value because it doesn't matter if it's a positive or a negative, it's going to go up or down at the same speed. The negative just says it's going down. So look at my little picture down here. My purple, y equals 2x squared. In red, y equals 1/2 x squared. So my coefficient got smaller. My parabola got wider. Down here, y equals -4x squared. The absolute value of -4, +4. So my coefficient got larger and my parabola got narrower. Take a moment to take it all in because it actually isn't that hard. It makes sense when you think about it. What if I want to take my parabola and do a vertical translation and I want to go up or down on the y-axis? Y equals ax squared plus c. When there is no bx, then the axis of symmetry is 0. And the y-intercept is c. The value of c determines the vertical translation. So coefficient a still determines if it appears to open up or to open down. But if the value of c increases, then the parabola translates up. If the value of c decreases, the parabola translates down. So here's my basic parabola right here where I'm crossing at the origin. Because I have no constant, it's +0, so I'm at 0, 0. All of a sudden, I change my constant to a -4. Well, -4 is less than 0, so my parabola went down, and my vertex is at -4. X squared plus 3, my vertex is now at +3. My parabola moved up. Very exciting, right? Back to this equation. The quadratic function, h of t, the function of ht, equals -16t squared plus c can be used to approximate the height, h, in feet, above the ground of a falling object, t seconds, after it is dropped from the height of c feet. So this is like saying this is your function equals -16t squared plus c. C is going to represent the feet, the height that it was dropped from. T is going to represent how many seconds it took to reach the ground. Again, the model is only approximate. It's like I'm putting a little waiver in there in case you're an actual, scientist doing an experiment. You're going to know that other things play a part in this, but not on a piece of paper for quadratics. You will need to solve the original height, which is your constant. That's easy. You just take the C value. Then you will need to solve for your zeros to determine the time. The zero is when the object hits the ground. It's also when it crosses the x-axis. So if an object is falling, the parabola is facing downward. Instead of giving you your quiz for homework, I've posted your quiz here because I want you to be able to take a look at it and see what the questions were. I did give you a copy of it in your Google Classroom so you can pull it out and you can look at it large. But mostly what I wanted you to know was that I gave you the answers, because I think there's too many of you that are going to struggle and go, I don't understand the question. But maybe if you see the answers, you will understand the question. Good luck. This was a nice short video. And good luck with transforming quadratic parabolas.